Welcome to all. So let us continue with the concept wherever we have stopped in the last video. So let me give the example for 3 variable Kmap. Okay, the Carnox map. So here you can see I have just zoomed in. So when you have 3 variables up to M7 you can have from M0 to M7. So that means total 8 possible cells. Okay, now if you see the image B, okay, you have x and yz. So x will take binary values 0 and 1, and yz will take 4 values, isn't it? 0 0 0 1 1 1 and 1 0. Okay, so based on that the cell value will differ. Say for example, when you have x is 0 and y z 0, everything is x dash y dash and z dash. So you are going to get the inverted variable. So when you have x equal to 0 and y equal to 0 and z equal to 1, or y z equal to 0 1, then you have, so wherever you have 0 you just have to put a dash or inverted thing, and for z, for 1 you are having the same variable as it is. You are keeping the variable as it is, isn't it? So that is the reason why. So when you have x and yz, you have x dash y dash and z. In the same fashion, when you have x equal to 0 and yz equal to 1 1, so at that time only x value is 0, that's why you have x dash, and y and z values are 1 1, so that is the reason why you are keeping the variable as it is, and the rest of things it goes as it is. Okay, rest of the cell also will have the same value in the same fashion. So this is how you can work on it. Now see, you when you have some equations, something like this, say for example m5 plus m7, then what you have to do. So what is the value for m5? So you can refer this. M5 is nothing but x y dash z, isn't it? So if you go for m0, m1, m2, m3, m4, m5, m6, m7, so that way if you go, so then m5 will be x y dash z, and m7 is nothing but xyz, isn't it? Same thing you are going to write here. So you can you can concentrate on that equation. Okay, m5 plus m7 equal to x y dash z plus xyz. Now here y and y dash you are taking common, isn't it? So xz of y dash plus y, that is nothing but xz. The answer will be xzy, because y dash plus y is nothing but 1, isn't it? So based on that postulate, you have to remember that postulate, don't get confused. You have to recall that postulate thing. Based on that postulate, y dash plus y is nothing but 1. So you are reducing x y dash z plus xyz to xz. So this is how you can go for the reduction of your overall equation. Now you can just concentrate on example 3.1. So simplify the Boolean function. So your questions also will be in the same fashion. So if they say that you have to simplify the Boolean function, so you can go for f equal to, say that function they have given, x dash yz plus x dash yz dash plus xy dash z dash plus xy dash z. So first one is marked in each square as needed to represent the function as shown in the figure. So that separate figure they have given. So you can concentrate here the figure, whatever the concept they have given. So they have represented the same thing using map example. Okay, so instead of going for theory, you can see wherever it is possible you have to put 1 from which place. So the cell which has the value x dash yz, isn't it? And based on those equations, wherever the equations they have given, wherever that function they have given, that function value, the cell has to be marked as 1. So this can be accomplished in 2 ways. Okay, either by converting each minterm to binary numbers and then making a 1 in the corresponding square. So you can either go for the whatever the minterms you have to make it as a binary one. Okay, binary number, then you can make then you can put 1 in the corresponding square, or obtaining the coincidence of the variable in each term. So you can go for obtaining the the cells which are very near to each other. So otherwise it is better if you go for the function itself, though wherever the functions you have x dash y z plus x dash y z dash, the same respective positions you have to put 1. That it is very easy for you to understand. Okay, for example, the term x dash y z has the corresponding binary number 0 1 1. From where they got 0 1 1? The value for x y z, whatever the value you passed for x y z, you can just a moment, yeah, here. So wherever the which one they said 0 1 1, so 0 1 1 is nothing but x dash y z. So m3 column, isn't m3 square in the figure B. The same thing they are saying here, yeah, 0 1 1. Okay, the number, binary number 0 0 0 1 1, that is nothing but x value is 0 and y value is 1 and z value is 1, and represent the min term m3 in square 0 0 1 1. Okay, so wherever the m3, the concept they have gone for it. Okay, the second way to recognize square is by the coincidence of the variable x dash y and z. That is nothing but wherever you have x dash is nothing but 0. Y is, when you have y, obviously the meaning will be input is 1, and whenever you get z, input is 1. So it is all about min term concept. Okay, in same fashion they represented the concept with respect to that squares or boxes. So 1 1 and 1 0, and for 1 1 is for that value when you have x equal to 1 and yz equal to 0 0, as well as when x equal to 1 and yz equal to 0 1. In that position they just have gone for they just converted that square with the 1 and 1. Now what is the next thing? You have to group the adjacent cells, isn't it? You have to group them, and once you group them, then you are going to get the better idea. Okay, now see, observe that x dash belongs to the 4 square in the first row. Okay, and y belongs to the 4 squares in 2 right columns. Okay, so that depends on again wherever you have the x dash things. So when you get x dash, when the x value is 0, isn't it? And when you are going to get y, so y is nothing but when you have y value 1. Correct? You have to get the y value 1. Now in first 2 columns, do you have y value 1? No, you have 0 and 0. For y you get 1 1 and 1 0, means the y value is 1, isn't it, in the both the case. But z value is, in one case it is 1, in the another last case it is 0. Like that you have to, the corresponding binary numbers you have to see. Based on that only you can come to one conclusion. Okay, now yeah, the same thing they have said, y belongs to 4 squares in the 2 right columns, because in 2 right columns you have y value. Okay, and z belongs to the 4 squares in the first in the 2 middle columns, isn't it? So in the middle of the columns you have 0 1 and 1 1, so z position is, in the both the cases it is 1. That is the same thing they are trying to say in the sentence. The area that belongs to all the literals is a single square in the first row and the third column. Okay, the first row and the third column you have that particular 3 square concept. Now the next thing is, so f are marked by ones in the map. So whatever the function they have given in the Boolean function, that position is marked as 1 in that particular square. The function is thus represented by an area containing 4 squares, each marked with 1, as shown in the in that figure. You can just concentrate. The next step is to subdivide the given area into adjacent squares. These are indicated in the map by 2 rectangles. Okay, each enclosing 2 ones. So they are grouping the ones all together. Okay, adjacent ones are grouped together. The upper right rectangle represents the area enclosed by x dash y. Now how they got x dash y? Because x dash is, because x value is 0, but y as it is. Why it is y as it is? Because y position is marked as 1 1, isn't it? So you are getting y itself. Okay, you are neglecting z in this case, because why you are neglecting z? Because you are not marking the 1 1 is not marked in the middle of the first row, isn't it? The middle column is not marked. You have right column, both the ones are in the right column. So that is the reason why you are neglecting z value here. The lower left, the area enclosed by is x y dash. Why it is x y dash? Because x value is 1, y dash, why you get y dash there? Because in the both the position y value is 0 0, isn't it? 0 0 and 0 1. So y position is in the both the cells, y position will be marked as 0. That is the reason why ultimately you are going to get the value as x y dash. The sum of these two terms give the answer f equal to this one, x dash y plus x y dash. So ultimately the whole Boolean function is minimized to this much. Correct. So consider next, consider two square labeled m0 and m2. So that figure they have said. So x dash y dash z dash, and which another one is x dash y z dash. That 3.3b, whatever things in the shown in the previous slide. So these two min terms are also also differ by one variable y, and their sum can be simplified into literal expression. Okay, so again that concept remains same. So x dash y dash z dash plus x dash y z dash. So what they are going to take, they are taking the common of x dash and z dash. Now y dash plus y is nothing but 1. Ultimately they are going to get the value as x dash z dash. Okay, so consequently we must modify the definition of adjacent squares to include this and other similar cases. So they are saying that in the rest of the example also, if you get one more example, ultimately the concept remains same. You have to follow the same step to minimize the Boolean function. Okay, you can take one more example, because if you solve more examples, it would be better for you. So again, you have simplified the Boolean function. So f equal to a dash c plus a dash b plus a b dash c plus bc. So if this is the case, how exactly you can work? Okay, so that means ultimately you have three variables, isn't it? A, b and c. Now a is nothing but, so in the same case, in the previous example you have taken xyz, but in this case you have taken abc. There is nothing new here. The concept remains the same, but the terminology or the representation or labeling of things, so it will be different. That's it. The map simplifies this function, shown in figure, the below figure. Okay, some of the terms in the function have less than 3 literals and are represented in the map by more than one square. For example, to find the square corresponding to a dash c, what to do when you have a dash c? Because ultimately you have 3 literals, but in the function, Boolean function, in some places you have only 2 literals or 2 variables they have taken, or 2 labels they have taken. Now how to deal with that? When you have 3 literals or variables, obviously you can work based on the previous example. In the same fashion you can work. But when you have only 2 literals, how to deal with that? Because if you are considering only 2 literals, means what to do with the third literal? Or if you go for a dash c, then where that b gone, isn't it? Where you have sent that b, isn't it? That will be a ambiguity. To overcome from that, see, they have taken the example. We will see the example. So we form the coincidence of a dash, that first row, and c, 2 middle columns. Now how to do that? And obtain the square 0 0 1 and 0 1 1. So you can just concentrate on the image. Okay, map, for example 3.6, that figure you can image. How to represent a dash c? Now when you have a dash, that means a value should be 0. That means obviously it is the first row. Correct? A dash. Now how to get only c? What to do to get only c? So if you want to get only c, then you have to mark the middle 2 columns, isn't it? Why? Because in 2 of the columns c remains 1 1. So that can be taken, isn't it? The function in this example has given min terms indicated by the 5 squares marked with 1s. So it is simplified by combining 4 squares in the center to give the literal c. Ultimately what they have done, they have gone for 4 1 1 1 1. So that means 2 sets. Why? To represent c. Why you are representing c in that fashion? Because see, I completely agree that a dash is nothing but when a equal to 0. But if you want to consider c as a whole, then you have to consider all 4 boxes or all 4 squares. Okay, the remaining single square marked with the 1 in 0 1 0 is combined with the adjacent square that has already been used once. So that is the same concept, because if you want to get only b, and if it is BC, how to do. So you can just concentrate on the equation here. Directly you come here. Just if you have any confusion with respect to explanation, when you solve you get the better idea. Now how to represent A dash C? Definitely A dash means in the first row. So obviously you are marking the middle two columns, isn't it? 1 1, because the C value remains 1 in that place. Now how to represent A dash B? Now A dash B is nothing but last two columns, isn't it? Rightmost columns, first row, last two squares. So that is the reason why continuously you get 1 1 1. You just forget about that boxes. Don't pair the boxes now. You just remain concentrate only on numbers, 1 1 numbers. Okay. Next, what is the next equation? You have A B dash C. That means A value is 1, B dash is nothing but 0, C 1. So where you get 1 0 1. So 1 0 1 is nothing but the second row, second column, isn't it? Second square, second row, second square. That is nothing but A B dash C. Now what is BC? So BC is nothing but definitely you have taken 4 ones, isn't it? So to represent BC, again you require 1 1 and in the last place again 1. So that is the reason why you just have taken BC as it is. So B, whatever the BC value you have, B is nothing but 1 1 and 1 0. They have marked, so you don't need to worry much on that. They have marked for A, B as well as C also. So after that, once you get 1 1s, then you can group these ones. So you can go for adjacent cells. So that is the reason why ultimately you are going to get this particular number. So when you have 4 ones together, you can go for 4 places. Okay, so you can mark it as 1 square, which consists 4 ones. When you have only 2 adjacent ones, then you have to mark only 2 adjacent ones. You should not be considering rest of the cells. Okay, this is how you can mark and you can write the equation using that. Now how to just work on that, you will see here. Okay, now in 3.7 what they are going to do, they are going to take some other example, but now don't consider the 3.7 right now. You just continue with the concept. The combination of two squares gives the term A dash B, while the single min term represented by the square gives the 3-variable term A dash B C dash. Now simplified function is f equal to c plus a dash b. How they got a dash b? So again this one, a dash b is nothing but, so whatever the a dash is on first row, definitely a dash means first row. Next only b, why you got? Because you have 1 1 adjacent 1 1s there in the b. Now C is nothing but you have 4 ones, so obviously you have to consider C. Ultimately what they have done, they have just written the function based on the squares, inside squares, isn't it? One you have C plus A dash B. The same thing they have written here. C f equal to C plus A dash B. This is how you can work on it. So this is the example I just wanted to take. So in the question paper or in the textbook you have some more examples. I will give some assignments to you so that you can solve. So if you get any doubt, you can get back to me. Okay, so if you want, you can simplify one more example. See here, f of x comma y comma z equal to that summation of 0 comma 2 comma 4 comma 5 comma 6. Now how to represent 0 comma 2 comma 4 comma 5 comma 6? Again you have to convert that numbers to binary. Based on that binary only, wherever the position you get, that position should be marked as 1, and adjacent cells should be taken as a square in the squares, and whatever the square you are going to get, the same thing you get the equation. Isn't it? So 0, when you have 0, the x, y, z value 0, where they have put 1 there. Now how to represent 2? That is nothing but 0, 1, 0. So 0, 1, 0 means last cell, first row, last cell, they put 1. Next, how to represent 4? So 4 is nothing but 1, 0, 0, isn't it? What is 1, 0, 0? That second row, first square. Now how to represent 5? It is nothing but 1, 0, 1, isn't it? So second row, second square, second row, second square. Now how to represent 6? It is 1, 1, 0. That is nothing but a second row, last square. Second second square, sorry, second row last square. So this is how they represented 0, 2, 4, 5, 6, and the equation is z dash plus xy dash. How? Z dash plus xy dash. So where you get z dash? So you get z dash when you have z value 0, isn't it? In the first column only, first row, first cell only, it is 1. So obviously you get z dash, and in the for the both the adjacent ones you have z dash itself. And how you get xy dash? Xy dash is nothing but x should be 1, and y dash is nothing but wherever you have that one concept, isn't it? The same thing they have gone for y dash. So this is how you can simplify the overall. How can you represent and how can you simplify? This is the better example you can get. Okay, so like this you can have so many examples, so you can take that example for your understanding. So and try to solve those examples which are available in the textbook or in the internet also. You will get so many examples for this map reduction concept, 3 variable, 2 variable and all. Okay, so if you get any doubt, you can send the screenshot to me. I will try to solve and I will get back to you. Okay, now you have one more concept called 4 variable Kmap. Now you have seen 3 variable map, 3k variable map, 2k variable map. Now it is 4 variable Kmap. Now how to do that? So again, when you should be having 4 literals here, wx and yz. Now both the wx are 0 and yz are 0, then it is m0. When you have wx 0, yz is nothing but 0, 1. 0, 1 means y is 0, z is 1. That is the meaning. Okay, now if that is the case, it should be marked as m1. And when you have wx 0, 0 and yz is 1, 1, so it is m3. So like this you can mark. And up to how much you are going to get? M0 to M15. So total 16 values you get here. Okay, in 4k k variable map. The number of cells in 4k variable k map is 16, since the number of variable is 4. Okay, now there is only one possibility of grouping 16 adjacent min terms. Let R1, R2, R3 and R4, or row 1, row 2, row 3 and row 4 represents the min terms of first row, second row, third row and fourth row respectively. Similarly, C1, C2, C3, C4 is nothing but the columns, respective columns. Now possible min terms grouping adjacent, 8 adjacent min terms are, that is nothing, R1, R2, R2, R3, R3, R4 you get. Next R4, R1 you get, that is the maximum row possibilities. Then you have C1, C2, C2, C3, C3, C4 and C4, C1 again. So these are the possible mapping you can go for, adjacent min terms. So based on this adjacent min terms only you have to map, or you have to put the square. Otherwise you won't get the simplified Boolean equation or function. Fine. So if w equal to 0, then 4 variable map becomes 3 variable k map. So you can reduce when one of the literal becomes 0 or w becomes 0. So this is the some of the information I just wanted to pass. The rest of the things I will definitely put one more video for this. So if you try to solve these things, you will get the better idea, but you have to take the example and you have to solve. Otherwise it will be a problem. Okay. Now if you get any doubt, just send the picture of it. Otherwise how I would get to know. So that is the reason why I am asking. So if you get any doubt, just try to solve these examples, and if you get any doubt, you just send the screenshot to me. I will solve it out. Okay, so yes, let me wind up the video here. Thanks for watching.